We're going to be looking at the sine and cosine graphs, and this is all based off of the unit circle. So if you're thinking about the unit circle, we know that my values are going from +1 to -1. And I also know when you're looking at these graphs of sine and cosine, you're going to want to look at them in terms of pi. So my suggestion would be to change your values here into pi. Now notice I use the points of interest that are on the unit circle because it makes it easier. On Desmos, you can change your step, and I'll show you guys how to do that in just a little bit, so that your steps are in terms of pi. It just makes it a lot easier as well. So again, notice I'm using all my points on my unit circle, thinking about my sine value. When I initially start here on my unit circle, my sine value is at 0. At pi/2, my sine value is 1. At pi, my sine value is at 0 again. And then at 3pi/2, I'm at -1. And at 2pi, going back to that same location, I'm at 0. So your sine function is going to follow that curve, and that should have hit there. Well, this curvature is just going to be replicated and transformed, translated, reflected, however you want to look at it, just over to the other side. So really not that big of a deal. And going on the back side of that. I am expecting that you know the sine graph without using Desmos, because once again, this is all based off of the unit circle that you should know that it's going through 0, 0, and that you can make that original sine parent graph without using Desmos. So moving on here, this next example is just discussing your transformations and just knowing how that is going to affect our graph. So the 3 here is going to be a vertical stretch. The 4, so this is opposite of what you see, because anything that you have inside those parentheses is going to be opposite of what you see based on our transformations. This is actually going to change the period. Sorry, let's go back here quick. The period, by the way, this is how long one wavelength is. So from here to here, that would be considered a period. Our wavelength is 2pi. And that will come into play when we're talking about the period. So anyway, we've got, with that 4, we have a horizontal stretch. You will sometimes see this called a phase shift. So if I'm supposed to graph this, here's what this does for me. Honestly, I'll probably just do the one side. I won't do the negative side. So the original graph, I'll plot this on here for you. Okay, so that's the original. And then the new one here, this is what's going to happen. You're still going to start at that 0, 0. But with that phase shift, what that means is that your wavelength here is now going to be 8 pi. So that's how long it takes to complete one wave. So thinking about that, by the time I hit 4 pi, I will technically only have completed from the original this portion of the graph. The other thing to note is with that vertical stretch of 3, my graph, so I know that I'm only going to 4 pi here. So I'm only doing that top portion of the curve, and it will reach a max of 3. So I'm going here to here, and that's all I would have. If I wanted to finish this out, I could go this way with it and have that stretched out that way. So again, the 3 is my maximum and my minimum, which we'll pretend that lines up. But again, that wavelength, it's just stretching it out, so it's going to take it longer to get there. Now the cosine graph, again, all based off of your unit circle. So if you're thinking through that unit circle, when I'm starting here, I'm starting at 1, 0. So my graph actually starts at the top. Then I go to 0. I go to -1, back to 0, and then at 2 pi, I'm back at 1. And there's my cosine graph. And again, I can translate this. I could reflect it. I'm still going to get that same curvature just moved over here. And there's my cosine graph. The other thing that I need to talk to you guys about that I didn't on the first one, which I have full confidence you guys know how to do this anyway. The domain here is negative pi to positive pi, or pi, negative infinity to positive infinity, and your range is from -1 to 1. Again, with the cosine graph, one wave is going to be completed in 2 pi. Now we've got some different transformations in regards to this. Now we have a -5 and a cosine of 2x. So first off, I have a reflection over the x-axis with that negative. The 5, I just have a vertical stretch of 5, and then I'm going to have a horizontal compression of a half, because again, it's opposite of what I see. So if I'm looking at that graph, thinking that I'm having a horizontal compression, it's going to take me half of the time to get to that wave. Now, a normal wave is to 2 pi. We should have made that a little taller. So the original graph goes there. Pretend it went through that point. Thank you. But now we're going to have that compression. I'm now going to complete that whole wave right there in half the amount. So I need to be done by that point. And the other thing to note is since I have a reflection over the x-axis, that would mean I'm really starting at -1. But I have that stretch of 5, so that's actually going to go down to the -5. Now I'm going to go, I know that I'm going to make that full loop, and I'm going to have to be done by the time I hit 1 pi. So I technically should be back here. Which means if you cut these points in half, that kind of helps to give you an idea. So this would be +5. So now I have this. So 1, it's reflected. And 2, I've got it stretched out to that 5, positive and -5. And then 3, that horizontal compression. My wave originally took me 0 to 2 pi. I now have to cut that in half. So I'm going from 0 to that pi here that I have to complete one wave. So it gets a little bit tighter. Okay. So then there's the other side of things. When you're talking about the amplitude, the period, these are all things that you're dealing with on those transformations. You just don't know that these are the fancy lingos. The amplitude, this is the number in front of your trig function. This is just your vertical stretch. That's all it is. The period is your wavelength. And this deals with your sine of bx. And this is opposite of what we see. So it's technically a horizontal compression of 1 over b. Or it could be obviously a horizontal stretch if you have it the reverse way. But your wavelength is decided by 2 pi times b. And we kind of talked about that a little bit already. So that's good to know. Or 2 pi times b, 2 pi divided by b. And then that phase shift, we'll talk about that one a little bit here. That's an extra piece that I need to make sure that you guys remember, because it's not something that we always remember. Looking at this next example, we were supposed to write an equation for the graph shown. So there's a couple different things that are happening here. First off, the red here is the original graph. So the red graph, I'm going through 0, 0. We know it's a sine graph. Let's just throw that out there right away. Since we're going through 0, 0 here, I notice that I'm technically going through kind of 0, 0 there. This right here, this looks like my new origin, right? If I were to take my x-axis and shift it up, it would be at that blue line I just showed, okay? So we have a +3 at the end of our sine. We already know that. I'm going to leave that there. That's that +3. Okay, so then the next thing that you need to look at is the amplitude. And the amplitude, how I look at it is you've moved that x-axis, great. Well, then from that new x-axis, how tall is that graph? 1, 2, 3, 4. That's your amplitude. Now, the last thing, which is sometimes hard to pick up on, is that's your wavelength, your horizontal stretch, shrink, compression. You know, what's happening there. So my wave normally takes me to 2 pi. But if I look at this, I'm completing the half of the wave by 2 pi. So by 4 pi, I for sure got it. So my wavelength is currently equal to 4 pi. So that means that I've got 2 pi over some type of b. Well, in order to get that, my b would have to be a half. So this now becomes x divided by 2 plus 3 as my final result. The one thing I do want to talk to you guys about that's additional, that is your left-right. Don't forget, if you have y equals sine of 2x plus 2, what ends up happening is a lot of people will say that they have a horizontal, in this case it would be a shrink, right, of a half, or a compression, however you want to look at it. And then they would say left 2. Now I'm going to tell you right now, that is wrong. It is not left 2. The reason why is because you have to remember that you need to factor this out. It is actually y equals sine 2 parenthesis x plus 1. That transformation has to be factored out. In order to get that horizontal shrink or compression, that number is technically outside of those parentheses. So this is actually left 1. Okay, so it doesn't seem like it's that big of a deal, but when you're marking that information down, it is. So when you're doing your homework and that kind of stuff, I don't care if you leave it in the factored form, or if you're going from the original, just make sure that you know that that needs to be factored at some point. The only other thing I want to show you guys is the Desmos and how to change it to what you need. I've already got this set up, so actually I'm just going to do a new tab so you can see it from the very start. So Desmos obviously is going to go from 0 to 1 as a normal step. Hit your settings. We're already in radians, which is awesome. Your x step, you can actually write this in terms of pi. I like to do pi over 2. You can change it to whatever you need. If you need it as pi over 3, it will show it. It's technically by thirds there. Just know that it might not show it with that number, and that's totally fine. The other thing is I like to make sure that my step on my y then is with 1. Just something to note. Obviously, you're not going to have perfect boxes or perfect squares there, because your grid is not in terms of 1 by 1. So just know that's why it looks rectangular. But now this can match up and make your graph a little bit easier. If you're graphing on graph paper, change that. Instead of one line being 1, change it to pi over 2, change it to pi over 3, change it to whatever you need to make your graph easier for yourself. If you're graphing it by hand, just making a sketch, just do what I did and just use the interval that you need. But I did want to show you guys that just in case you forgot. But otherwise, that's the sine and cosine graph. Just talking about those different transformations. Again, should be review, but just as a reminder. Okay?